Hello, and in this part we're going to start building out the core model, as you can see here in my scene. So here in Houdini, I'm going to start out with a sphere, because the core is a sphere shape. And I'm going to set it here on polygons, and we are going to increase it. So what I want to do now is to create sort of panels on this sphere. So if I go back here to Unity, we can see that my sphere has been cut out in different panels. So I would like to build a system that cuts out these panels automatically in my model. There are a few ways we can do this. We can, for example, use the voronoi fracture node, which is really cool to use for this. And our first input will be the sphere, and my second input will be a scatter node. The scatter node will create points on the sphere, as you can see. So right now we have around 1000 points, which is too much. And I'm going to lower this to around, let's say, 200 for now. And I'm going to connect this in here. And if we view the result, we can see that there are now sort of like pieces in there. If we visualize what we are doing here by clicking on this icon, we can then see these shapes generated. So this is what I would like to have, is to have a system that makes these shapes. So maybe they're still too much. Then we can select on how many parts or panels we want. Also note that they are not perfectly same size. You can always go here and start relaxing the shape, and it will get a bit better if you play around with these relaxing options. But this is also great if you want a look that has a bit more randomness to it. If you want a look that is quite consistent, then this will work. But if you also want to have a look, for example, like this, where it's not that consistent and more random, that could also be nice to have. Also with this technique, this is used often for destruction, where the voronoi node, if we, for example, use an explode node, we can then see that there are also geometry inside now. So if you would use this in a simulation, the sphere would fall apart in these pieces. But I don't actually need those inside pieces. So in here, we can then disable the interior faces. As you can see here, they are now gone. So we only have the outer shell, which is what I'm actually looking for. We also have a global C10, of course, for getting a lot of variations. There is also another way we can create something like this, and we can start using a sphere here again, and I'm going to set the frequency on 2. So we have this shape, and on that shape I will be using a divide node. And in this divide node, I'm actually interested in the last setting here, compute dial, and then we get this result, which is also pretty nice, and this is more consistent in its placement of the shape, which in here, there are cases that some parts are not equally sized, so there is some randomness a bit going on. Well, if you're looking for a more consistent look, then this might be a better option, where we can see that pieces are more equally. You can also build further on this. You can also start adding a boolean, so like this. And then if we lower the size here a little bit, we can start getting these faces in there. So that could also be cool to use to get more variations of the core. Based on what you have in mind for your core, you're gonna have to find out the base shape and then work from there. But I'm gonna continue here with my fracturing, and I'm gonna build on top of this. In here, what's interesting to know is that all pieces are not attached anymore. As you can see, I can just drag and drop one piece out of there. So I will be using that in my advantage, and I will be using a for loop, and I can say for each connected piece, I want to loop over it. So we're gonna loop 32 times, which is the equal amount that I've put in here. So everything that we do here in the loop will be done for every piece. So as example here, let's take a simple extrude, and we can start extruding this piece. and we can, for example, give it an inset. Now, I noticed in this case that the inset is not really working always nicely on these shapes that we're generating. So what I did here in spline control, we can go scroll down here and we can adjust the thickness scale, which also has a similar effect in my case to the inset and is also a bit more smoother. So if I do this here once, this means that every piece will get this extrude. So that's the idea behind this loop, is that we model one little shell, like we model one piece here like this one, and the loop will repeat this process for every other piece. So we don't have to model it manually, it's just looping over the same nodes. We can also disable the color by clicking this icon here. So now we have the basic ID. So we're gonna model one piece in the style I would like to have, and then the loop will do it for all the pieces. So I'm gonna make some more room here because I'm gonna create multiple extrude nodes here. So let's start modeling. And I also would like to close my backside. So here, close the back. This will come in later handy, so I know my backside is closed. Then for my first iteration, I want to have something like this. So the back is closed and I have like a small inset or thickness scale difference. Then I'm also going to save out the front group because I want to do this process procedurally, and I'm going to save information in the front groups. And in my case, I'm already going to number it, so I still know a bit what's going on. Then I'm going to take a new extrude node, and I can fill in then my group I just made, the extrude. And now we can then extrude this part procedurally. So now we can then extrude this part, and similar here, I might lower this thickness scaling so it looks better. Here I would also like to save the front group extrude. Now what can be interesting is that we can also put a one in here. And if I just simply copy this node, we can see that it's adding on top of the extrude I already had. So this is a small trick for doing this procedurally, is that I can keep copy pasting this node and it will do the same operation over and over again procedurally, as you could see here. So in this case I have something like this. I'll copy it again. Maybe it's going a little bit, maybe it's going a bit inwards. Maybe it's going inwards, but I notice I have my piece close here, so maybe this piece is coming out more. So I can put this more in the back. Maybe something like this. So yeah, so I'm basically going to repeat this process by copying extrude nodes and then changing the values. So I might speed up this part. You can model along or make something you like. So then you can have something that looks like this, and let's plug that in the for loop. And let's see the result now. And as you can see, as expected, every piece has now been procedurally modeled along the way I build up here. So they have the same steps and same shapes. Now, one thing I already want to include in here is, if you look in Unity, I have this glowing edges around these parts. So right now we are building a part like this. So I also want to save information where I want to have these glows. So we basically can, if you go, for example, to the first extrude, What if we start, for example, saving out the side group? So this is the side group. And what if I call this then glow? So in the end of the loop here, if I would color the group glow, you will see that then the side part will have this color. So blue. So we can see this part here. So we can see that this part has now this blue part, which I can then use in a color map. So I can render this out in a color map. So my material knows that, oh yeah, everything that's this color needs to glow. And I can do this process then for other parts. So if you have a part that you want to have the glowing effect on, you have to go back to the extrude node and then enable the side group and then store this information. So maybe I go back up here somewhere. And you can always double check here by disabling and enabling the output here. So this one could be interesting to have a glow on. Or maybe I think this one could also work. So glow. I want definitely this part. I also want to save in the glow group. And if you look here, we have now all these blue parts will have glowy effects. So you might also notice these groups are adding the glow to each other. So I have multiple glow groups. So for example, in the first node I made a glow node, and then here somewhere I also made a glow node, and they will be adding to each other, which also here stands for preserve groups. So if we do this for the whole network, we have then this effect. Then I would like to add a few more details on this core, and I will be making more plays here again. And what I would like to do is to, for example, Boolean shapes in here. So this might be a little bit more tricky. So what I can do here is I can, in my case, start from this point, and I'm going to use a blast node, and I will blast away everything except for the extrude group. So revert setting, everything. So I have only this piece here. So then based on that piece, I want to have some booleans here on these edges. I want to have a certain shape boolean in here. So what we can do is I want to first of all clean up this shape, and the easiest way I found is that we just use a poly reducer. So poly reduce, and then we set it to a low percentage. Let's try 7. So that already looks okay. And we can also use the original points. So if I would compare these shapes, is that we have now extracted these corner points, as you can see here, by using the poly reducer. There are of course other ways of doing this, but I found the poly reducer the easiest one where we get this result. Then I use the divide node, and in this divide I disable the convex polygons and I enable the remove shared edges, and this will basically result in a flat plane that I have now. You can also immediately do this from here, and then everything in the middle is gone, but we have still these edges here that we would need to clean up. So what I then would like to do is I would use a convert to line. So this means that every single line is now a primitive. So if I enable the primitive numbers, we can see that we have number 1, 0, 4, 2, and so on. And here, Houdini sees this as one big primitive, just 0. And then convert line, every single line is now a primitive. And then we can use this in our advantage by using the carve node. So with the carve node, we then can control how long each line is. So as if I enable the first U and the second U, we can then control the length of the line, as you could see. So this information I want to use in a boolean. So first of all, I need to give it a shape, and we'll be using the sweep node. And in the sweep nodes, we have a feature now for adding round tubes, and I will be reducing the radius. And I'm also going to close the caps, because if you're going to use this in a boolean, it might be better if this is a closed shape like this. We can also add a grid, and then we have a more roundish ending, which can also be nice. So this can then be booleans. So this input with this one, and let's see what I will give if I subtract it. So now I have boolean in some details here. So you can still play around with some of the radius or the length here, like 0.6 and 0.3 here maybe. And then we can then use this then for every system. And I can see that most of the time it is working. There are a few cases here where it's not properly working. Let's solve that issue. So you can always debug the loop by using single pass. So we pass over each single piece. So we have this piece. And in my case, what helped was placing a fuse here. So without the fuse, it creates this geometry, but with the fuse, it then creates a result that I would like to have. So as you can see here, some points are close to each other, and then we fuse them together into a nice line, which then helped here for the boolean. So if you disable single pass again, we're gonna do the full loop. And now everything seems to work nicely. You can repeat this process here by using another shape. So let's say I copy paste this and let's plug it in here. So then we have another result that can be used for then pulling out pieces over here. So you can repeat the same process to get more variation. Or you can, of course, build different systems to get more variations. This is then my base for the core. And now I want to create some outer panels to put on these shapes. So I'll go back up here again. So you can do the same process actually. And you could also do this without a for loop. If you just use like simple extrusions, you can do this. As you can see here, without a loop. So as you can see here, we can also do this without a for each loop if you just do like simple geometry stuff. So then we're going creating an outer panel, and here as well, going to the groups and exposing the front group. So I can keep using this information here, so I can get variations in shapes. So based on what you would like to see, you're gonna have to model again here what you want as a result. But in my case, as you could see here in Unity, I don't have these panels on top of these pieces everywhere. So I randomly selected a few and I deleted them. So we'll be doing the same here. So as in my approach, I assembled the pieces. And you're gonna pack them. So each piece is now being packed in a single point. So as you can see here, we are not working with geometry here. I cannot select an individual face. I'm selecting the whole piece because they are being packed. And I can then use this in a group arrange node. And in the group arrange node, I can then start here selecting then pieces. As you can see, I have now selected some pieces, and then we can blast it away. So I just called it group 1, so group 1, and here we have deleted them. So then for my extrude nodes to work back again, because right now they are not working anymore, we have to unpack the geometry. So here in the assemble node, we packed the geometry so we can have points, and then we deleted some of these, and now I unpack them back so I can actually have a few pieces missing. Then if you merge these results together, so if I merge this one with this one, so hold an Alt button and then drag and drop that, I can now see that they're not properly aligning. So in my case, I have to scale up this part so they are coming on top of the other part. And I'm going to use a transform node for that. And I'm going to do it here before the system. You can also do it afterwards if you want that. And we can then scale it a little bit, like 0.6 maybe. So you can play around with this group range nodes, and we can have then the variation, as you can see. So in my case, my sphere is also nicely in the center, so I don't have to align anything. I know that if I just use the scale here, my sphere is perfectly scaled. So you have to watch out if your model is not in the center. Like if your model is like this, you can see that if your model is off center, the system is not gonna work nicely then. And I'm also going to store this in a group as well. So this whole information, I'm gonna call them panels. And the reason again for that is here, so we can color it. So in here we can color the glowing pieces, but now we can also start coloring the panels. So if I would go here, panels, and let's make them orange, for example, we can start coloring different pieces for our material ID. And the last thing for my core is to have like some structure around them. So from this transform node, I will be using a divide. And with this divide node, I click the remove shared edges. So we only have this wireframe. And what if we polywire this result? We now have then this. So let's also lower the radius, add some more divisions so it's smoother, which again we can then use in here and merge that in this part. So we have this support structure going on. You can also then here fine-tune the scale maybe again. It just depends. It's gonna depend on what you want. So maybe it's more like this. If you also would like to give an ID to that piece, you can also again use a group to save that information. That was it for this part. So this part we made this core piece, and it's quite procedurally set up. If we then go back here and change the number, then we have different results, as you can see. So we have a system where we can then choose which variation I would like.